So this is pretty good, but there's actually one of these machines that you're all much more familiar with because you use it kind of all the time, right? The much more well-known 10-1 machine, exactly. So let's take a look at the 10-1 machine for a minute. Okay, so this is the 10-1 machine. And I'm going to put, I'm too lazy to draw this many dots, sorry. I was just telling Tom Davis a joke early this morning, which is, if somebody asked me, describe yourself in 3 words, lazy. All right, so I'm too lazy to draw 473 dots, so I'm just going to write 473 here. Yeah. So what's going to happen when I put 473 pebbles or 473 dots or whatever into that box? Whoa, wait, you're leaping way ahead here. What's going to actually happen? There's going to be 47 explosions. And what's the consequences of the 47 explosions? 3 pebbles left in here, and 47 in the next box over. Then there's going to be plus 4 more explosions. Yeah. And there'll be 7 dots left in here. 7 pebbles, whatever I want to call them. And 4 explosions, so there'll be 4 in here. But of course, if I was drawing this to scale, it would look more like this, right? Because each of these is 10 dots all glommed together. And maybe if you can imagine it in 3D, they wouldn't have to be that huge. And these are going to be really big. Okay. So, I mean, how much does each of these dots actually have to weigh? How much do these pebbles have to weigh to make this work, assuming that we start with the 1-ounce pebbles as usual? 10. 100 ounces. And so we still have 473 ounces of pebbles, right? Now, wait a minute. In this last one, we said there are 27. There are 23 explosions and 1, 2, 3, 4 pebbles left. Here I had 473 pebbles. Right, so up here I had 27 pebbles, 23 explosions. Oops, wrong color. Got to keep the excitement up. 23 explosions, and 4 left. And here I had 473 pebbles. I had 51 explosions. And then that looks like 14 pebbles left. But here it was so nice. 27 equals 23 plus 4. And it all makes sense. And here it's 473 equals 51 plus 14. That doesn't work out so well. There's something wrong. This 51 plus 14 doesn't equal 473. Now I'm sad.
Choose 9 pebbles every time.
Oh. Up here, 2 pebbles explode and I get 1 for a net loss of 1 pebble per explosion. But here, go ahead.
You start with 10 when you explode, still 1, but you have 9, you lost 9.
So here the 23 explosions minus 1 pebble each. Here the explosions are minus 9 pebbles each. 9. Okay, so here I have 27. I could kind of say minus 23 destroyed in explosions equals 4. But here, that same equation would look like 473 minus 51 groups of 9 should leave 14. That looks like it has a chance of being true, unlike 473 equals 51 plus 14, which I could immediately tell isn't. Let's see. That's 459. Hey, that actually is true. Cool. Thanks. Okay. And I don't know, have you ever learned the idea that to test whether 473 is divisible by 9, you can look at 4 pebbles plus 7 pebbles plus 3 pebbles equals 14 and see whether that's divisible by 9 or not? Have you seen this test for divisibility by 9? So why does it work? Well, it's because when you put 473 pebbles in your machine, you take away a whole bunch of 9s, and you have 14 left. You could keep taking away 9s until you get down to the remainder. You know that the remainder of 14, when I divide by 9, you can just see it. It's going to be 5. But if I take away a whole bunch of 9s, this original number must have that same remainder too. So 473's remainder when I divide by 9 is the same as 14's. So I can test for whether things are divisible by 9 by just counting the pebbles, because when 10 pebbles explode and turn into 1, I've just taken away 9 pebbles. Still the same situation as far as divisibility by 9, which is pretty cool.